Number 6, the functions f and g have continuous second derivatives. The table above gives values of the functions and their derivatives at selected values of x. Part A, let k of x equal f of g of x. Write an equation for the line tangent to the graph of k at x equals 3. Right, big thing right here. Equation of a tangent line. When you are done, your answer should look like y equals mx plus b. If it doesn't, you did something wrong. Okay, the y value. Let's see if we can find the y. Well, actually, the x value is 3. To get the y value is going to be k of 3. And we know that k of 3 is going to be f of g of 3. So g of 3, if I look it up on my chart, is 6. And then f of 6, if I look up that on my chart, I will get 4. So y equals 4. So x equals 3, y equals 4. I need m, which is a derivative, which means I need to find k prime of x. All right, so we know that k is equal to f of g of x. I see parentheses, so I'm going to call this u. So over here, u is equal to g of x. The derivative of that would be g prime of x. So if I take the derivative, so this is now f of u. If I take the derivative of f of u, it's going to be f prime of u times du. And let's just put our u's back in. So I'm going to take f prime of g of x times du, which is g prime of x. All right, I'm calculating it at 3. So now I'm going to put 3's in for my x's. And now I get to look some stuff up on my chart. So f prime g of 3 is equal to 6 times g prime of 3 is equal to 2. And now here, f prime of 6, if I look that up on my chart, I get 5. So 5 times 2 is 10. So k prime of 3 is equal to 10, which means that is my m. So I have 4 equals 30 plus b. That makes b equal negative 26. So the equation of the tangent line was y equals my m, which was 10x minus 26. We could have also written it as y minus our y value, which was 4 equals 10x minus our x value. So that would have been okay to do as well. And that was worth 3 points. Holy cow. So we're going to get 1 point or 2 points for finding the slope at x equals 3. So if you found that the slope of the line was 10, that was worth 2 points. I'm guessing if you made a mistake getting there, you might get one of those 2 points. And then if you have the correct equation of the tangent line, you got your 3rd point. So again, this was worth 3 points. Okay, part B, let h of x equal g of x over f of x. Find h prime of 1. Well, I notice that this is a quotient, so we are going to use the quotient rule. So getting this quotient, it's going to be f prime g, but the g and the f are backwards this time, so it's going to be g prime f. So it's going to be g prime f minus, and it's usually this is usually f prime g, and the other one is f g prime, so it's going to be g f prime and then this is going to be all over g squared, or the bottom squared, so f squared. And all I did, if that confused you, if you're Mrs. Gaines' class, you guys do high, D, low, so that was not confusing. But if you are in my class, the f and the g were backwards, so I used my formula backwards. Okay, so now we're just going to plug in 1 wherever we see an x. So g prime of 1 times f of 1 minus g of 1 times f prime of 1 all over f of 1 squared. So looking these values up, we are going to get g prime of 1 is equal to 8. So I'll have 8 times f of 1 is equal to negative 6 minus g of 1 is equal to 2 times f prime of 1 is equal to 3 all over f of 1, which is negative 6 squared. So this will be negative 48 minus 6 over 36, and that will be negative 54 over 36. If you'd like to reduce it, go for it, but you don't necessarily have to. That would reduce to negative 3/2, but I cannot get my pointer to work. There we go. It reduces to negative 3/2. So this part was worth 3 points once again. If you found an expression for h prime of 1, so if you have this on your paper, something that looks very similar to that on your paper, that was actually worth 2 points. So I'm guessing if you made a mistake halfway through, you might have gotten 1 of your points and then 1 point for getting the negative 3/2. Okay, part C, evaluate the integral from 1 to 3 of f double prime of 2x. So I see parentheses on this one again, so I'm going to do a u substitution. I'm going to let u equal 2x. du is going to equal 2, which I don't have a 2 on the inside, and I'll put a 1/2 on the outside to make up for that. So I'm going to have 1/2 the integral of f double prime of u du. Okay, now from here, the integral of f double prime, that just brings us back a derivative, so that's going to be f prime of u, and that we're going to just carry down our 1/2, and I'm going to plug my u back in, so it's going to be 1/2 f prime of 2x, and then there are points to evaluate it at. We're going to evaluate it at 3 and 1. So if I plug in 3, I'm going to get 2 times 3 is 6, minus 1/2 f prime. If I plug in 1, I get 2. And now it's just looking things up on the chart again. So it's going to be 1/2 times f prime of 6 is equal to 5, and then minus 1/2 times f prime of 2 is equal to negative 2. So just working that out, I'm going to get 5/2 plus 1. And if I simplified that even farther, I would get 7/2. But again, leaving it as 5/2 plus 1, that would be okay too. This was worth 3 points once again. So if you correctly took the antiderivative, you got to this part right here, that was worth 2 points. If you made a mistake somewhere in between, you probably got plus 1 of those 2 points. And then if you correctly found the answer was 7/2, you got your 3rd point. So again, that was worth 3 points.